Good evening, everyone. It's wonderful to see you all here. My name is Nicholas Brown, and I'm a faculty as well as the director for the bioethics minor at LMU's Bioethics Institute. And on behalf of myself and all of us here at the Institute, I would like to thank you all very much for coming out for this evening, for what promises to be some very rich and engaging ethical reflection and conversation on a subject that is drawing an increasing amount of public attention and debate, that is germline modification, or as it's also referred to sometimes, gene editing. So to guide us in this very worthwhile endeavor, we've assembled a very august panel of experts who bring a wealth of expertise and knowledge and wisdom to bear, and I would now like to briefly introduce them. Our opening presentation, which is entitled The Uneasy Journey to Embryo Experimentation, will be given by Dr. Roberto Dell'Oro, who serves as the director as well as a full professor at the Bioethics Institute. This will be followed by Professor Jennifer Boomer, who is a part-time faculty at the Bioethics Institute, as well as a practicing attorney at the prestigious Gibson, Dunn, and Crutcher firm here in Los Angeles. Professor Boomer's presentation is entitled The Ethics of Germline Modification. And then our final presentation for the evening, A Legal Puzzle, International Relations, will be provided by Dr. Cesare Romano, who is both a professor of law and the W. Joseph Ford Fellow at Loyola Law School. So each of these presentations will be approximately 20 minutes in length. And at the conclusion of Dr. Romano's remarks, we will open up for questions. Both those you would like to pose to the panelists, and perhaps some of the panelists or all the panelists may want to pose to each other as well. A reception is also going to be held just outside here as well following the conclusion of the event, which you are all welcome to attend. A very small housekeeping matter to attend to. If you need to leave or depart prior to the end of the event, we would ask if you could please use the exits at the back, the auditorium, rather than coming back here so as not to disrupt visitors. So before we have Dr. Dell'Oro's remarks, we thought it would be helpful to play a very short video which gives us a better understanding of some kind of basic rudiments of what we mean by gene modification, and to get a better understanding of kind of what the technological tools that are used in this particular kind of process. So we'll play a very short video, and then following that, we'll have Dr. Dell'Oro's remarks.
What is gene editing, or genome editing as it is also known, and how does it work? Let's start by talking about genes. These are sections of the long DNA molecules coiled up inside each cell of every living thing, from microorganisms and insects to plants and animals, including humans. Think of DNA as the instruction manual for an organism. In people, genes can influence characteristics such as your height and the color of your eyes. DNA is inherited from our parents. We have a combination of two sets of genes, one from each parent, brought together to produce a new set of instructions and reshuffled in each generation. But sometimes these instructions carry errors, and these can create problems. Faulty genes can cause serious illnesses. Humanity has a long history of figuring out ways to modify genes. We have been crossbreeding plants to make them better to eat for thousands of years. But with gene editing, we've made a great leap forward. This increasingly accurate new technology is faster to use, relatively simple, and cheap compared with previous methods, and promises huge benefits. In a nutshell, it works by identifying, then cutting pieces of DNA. One way of doing this uses a component known as CRISPR to pinpoint the precise DNA sequence within the gene to be altered. Then an enzyme called Cas9 snips through the DNA, changing it or allowing it to be replaced by another stretch of DNA that is introduced at the same time. This can either replace a faulty gene with a healthy one, or change a gene to make it behave differently. The methods act like a find and replace for the genetic instruction manual. By making these microscopic changes to DNA, gene editing has the potential to make big changes to our lives. Gene editing is already transforming genetic research. But at this early stage of such a powerful technology, it's crucial that we weigh the potential benefits against the possible negatives. First, let's look at the positives. Gene editing could make radical improvements to human health. For example, in 2015, doctors used genome editing techniques to cure a baby girl's leukemia. In the future, we may be able to fix the gene mutations that predispose some people to cancer, or enable new therapies for HIV, or edit the genes that cause hereditary diseases. In the plant world, it could make crops more nutritious, disease-resistant, and able to grow in difficult conditions. By editing animals' genes, we could help them resist diseases. Scientists are currently working to edit the genes of mosquitoes to prevent them from carrying malaria. So genome editing has enormous positive potential. But what about possible downsides? Genes could be edited in early human embryos to alter characteristics such as eye colour that have no bearing on health. This raises the possibility of designer babies. And changing an embryo's DNA would not only affect the child, but their descendants too. These same techniques could also be used to create designer pets, or develop more virulent microbial diseases. So, alongside the many benefits of genome editing, there are also some ethical and societal concerns to consider. The technology is already in our hands. Now's the time to debate how we use it, regulate it, avoid negative uses, and unlock its potential to provide life-changing solutions to some of the world's biggest challenges.
Good evening, everybody, and thank you for coming tonight. As Dr. Brown has indicated, this is a very difficult topic. I don't think any one of us has a pretense here to offer a final answer. Certainly my function in these first 20 minutes is to offer something like an ethical mapping of the question and to bring up some of the key ethical questions that I think are involved in thinking about germline modification. It is very difficult to speak about germline modification without bringing up the case that emerged during the 2018 International Symposium on Human Genome Editing, because that is really what brought germline modification into the news and ultimately into the public discussion. The case is, of course, the case of a Chinese doctor, Dr. He Guanghui, from Shenzhen University, who in the midst of this conference announced that he had created the first genetically edited babies. So it's important to think about the fact that, of course, the conference that brought together scientists and ethicists was supposed to, on the one hand, come up with the state of the question on scientific research in genome editing at the basic science level, but no one really thought that it would be a good idea to actually start genome editing people. Thus, you can imagine that this particular announcement came as a complete surprise. What is it that Dr. A did was to delete a particular gene in two embryos that were successfully implanted in a woman. The gene is called CCR5, which makes the body resistant to the HIV virus. obviously HIV is a big problem in China, and he thought that intervening genetically on the question would be a way to push gene therapy ahead. What was the problem with the experiment? Well, certainly it was the fact that, first of all, we are not clear about the effects of that intervention, both at the level of basic research and also at the level of initial clinical trials. We, for example, know that, of course, to make the body resistant to the HIV virus by deleting the gene in question might have certain effects on other genes. For example, it makes the body less resistant to the potential infection of other viruses, for example, the West Nile virus. And so this brings up immediately the problem of how touching the human genome is a very complicated and, in fact, very ambiguous question, because we don't really know what kind of effect it would have. Remember, this particular intervention is an intervention on germ cells, meaning it's an intervention that will affect not only the twins that were eventually born, but in fact the progeny coming from these twins. Thus the modification obviously has a weight that I don't think Dr. A really thought about very carefully. Now, I don't think that we should think about genome editing by keeping this particular case in mind as the starting point of the conversation. In fact, we should take that particular case as something to forget. At the same time, it seems that that particular case brings into relief what I would consider to be the two ethical fields that articulate for us the potential ethical problems involved in genome editing. And that is because genome editing stands at the crossroad, if you want, of two fields of reflection in ethics. The first one is the ethics of medical research. Why? Because obviously this is a new research. Secondly, the ethics of artificial reproductive technologies. So I would like to go through the ethical components of these two, shall we say, different language games, if you want, in order to then raise three final questions pertaining more specifically to genome editing. So let me get to the ethics of medical research. Germline modification builds on the successes of previous genetic research. And the previous genetic research in question here is either basic research carried out in the laboratory, or it is research on somatic intervention, so-called gene therapy. Now, the difference between this particular kind of research and genome editing has to do with the fact that whereas somatic intervention is an intervention that will affect the person and only the person, germline interventions, as I said, will affect the progeny of that person as well. So there are elements of continuity and discontinuity between the previous research, the somatic gene therapy research, and the germline research. At the same time, we have to recognize that gene therapy, somatic intervention, has already produced some interesting results, and therefore it is a very exciting field of study. We have, in fact, potential gene therapy ex vivo, that is, therapy in which cells are taken out of the body, edited, and then returned, reinserted into the body. So, for example, immunotherapy entails the editing of blood cells for treating cancer. The same can be had for HIV. We can edit blood cells for sickle cell diseases, such as sickle cell anemia, thalassemia, etc. Gene therapy can be had also as an injection in the body, so-called in vivo research, by a change that directly in the body affects the genome of a person. So, for example, we have experiments that have already carried out the editing of liver cells for hemophilia, as well as the editing of muscle cells for Duchenne muscular dystrophy. So those are all horrible things, and we should say, what a fantastic achievement that we have made this kind of experiments. At the same time, we need to be reminded of the fact that already at this level, at the level of somatic gene therapy, certain protocols entail both benefits and potential burdens, benefits and potential side effects. So, for example, you probably recall the case of the so-called bubble boy, a boy who was, because of a severe immunodeficiency, forced to live in a bubble, literally, because he could not sustain the interaction with the outside world. Protocols already in the early 90s were begun, where this particular kind of immunodeficiency syndrome was addressed. Unfortunately, we discovered later on that intervening on this particular gene or set of genes would actually trigger other problems, for example, causing cancer in those who had undergone this particular experiment. But to remain positive about the field of gene therapy, we should recognize that as of today, we have more than 500 gene transfer or gene therapy research protocols underway. And again, that's a good thing, provided, of course, these protocols remain within the boundaries of ethical experimentation. So what are those boundaries? And don't get fooled by the rat with the ear growing on the back, but it's always good to sort of show it. We are talking about human subjects, so we are not talking about animals, though, as you know, every research with human subjects has had animal experimentation behind it. So, somatic cell therapy has, of course, an ethical framework that guided it for the past, I would say, 30 years. And this framework is made up of very specific ethics statements, from the Nuremberg Code to the WHO declarations, Helsinki being the first, but the declaration has been revised several times, to, in America, the Belmont Report from 1978 that eventually constitute the basis for the so-called common rule, that is the code of federal regulation that in a way drives the regulatory framework of every kind of experimentation carried out with federal funded research. What does this framework entail? Entails the so-called respect of 4 principles which constitutes the basic framework of bioethics. Any bioethics student has this particular book, Principles of Biomedical Ethics, by Bishop and Childress, as a kind of Bible next to him or her. And the idea is that one has to understand that ultimately research is ethical when it's being carried out in the respect of 2 fundamental principles. First, informed consent. So you can't undergo experimentation of any kind without the consent of the subject. And ultimately, there has to be, in addition to a valuable scientific goal, a proportionality of benefits and burdens. A proportionality of benefits and burdens that safeguards the fundamental principle of medicine and therefore also the fundamental principle of experimentation, and that is do no harm. So now think back about the Chinese doctor's experiment. Okay, first language game, the ethics of research. Let me now pass to the second language game that we can use as a kind of prism through which to look at genome editing. And that is the field of artificial reproductive technologies. This is a field that has been in place since 1978. You probably recall, or you can recall, because you were a student born, most of you, the birth of Louise Brown, the first baby born with artificial reproductive technologies, which are now sort of obvious in the field of procreation and reproduction, for the fact that over 1 million people in the world have been produced with these technologies. Let's not get into the ethics of it for now. Now, the original intent of those technologies was to provide a therapeutic measure for a pathology in the individual or the couple. The inability of one of the partners to reproduce, to conceive. And I would say that the original intent of artificial reproductive technologies was to create a continuity, in fact a biological continuity, between parents and children. The idea was, I want a child of my own. And because I'm not available for the obvious alternative, which is adoption, I want to go through whatever medicine might offer. Now, if we look at the development of artificial reproductive technologies over the last 40 years, we see that a lot of things have happened that in a way have not any longer to do, or not entirely to do, with the original intent. Or if you want, we have developments that have long surpassed the original intent of artificial reproductive technologies. For example, we have donation of gametes, sperm and egg. We have surrogate motherhood, that is the possibility for a woman to carry out a pregnancy with an embryo that is not her own. We have the reality of embryo donation. You can buy or even sell embryos. We have cryopreservation, the possibility of maintaining embryos that are not implanted into a woman for a long time. And we have the reality of pre-implantation genetic diagnosis. So I want to focus simply on the last aspect. Because, in a way, pre-implantation genetic diagnosis offers the link between artificial reproductive technologies and genome editing. Well, we do know that pre-implantation genetic diagnosis was initially used for sex identification to avoid transfer of embryos with X-linked genetic disease. So you do know that there are diseases affecting males more than females because those diseases are caused by genes on the X chromosome, right? And most of these diseases are X-linked recessive genes which affect predominantly males. So PGD was introduced when an individual or a couple wanted a baby but did not want to pass on potential problems that were linked with the X chromosome. Lesch-Nyhan syndrome is, for example, one of these problems, but certainly we can refer to other problems like Down syndrome, Turner syndrome, cystic fibrosis, Tay-Sachs disease, and so on. If you remember the movie My Sister's Keeper, I don't remember whether the movie had the same title than the book, but I read the book by Jodie Picot. You probably remember the plot in the book is, of course, the couple has a child that develops cancer. They want now to produce a baby that has the same type of cells in the bone marrow to be transplanted into the sister with cancer. This is also known as HLA typing. So PGD serves as a technique whereby you can produce several embryos. You test those embryos out by teasing out one of the blastomers of the embryo at an early level of development. You can check the genome of the blastomer and can say, okay, this is the right embryo, therefore we implant it. What are we doing? PGD can identify genetic markers that correlate now with hundreds of diseases. Now you see that, of course, this technique is starting to push artificial reproductive technologies on the way to something else. And the something else might be the attempt to, shall we say, avoid passing on certain bad genes, but it could very well be also the attempt to create a particular baby, a particular designer baby with certain genetic characteristics. So, if we now get to the human genome editing questions, by putting together these two different frames, the ethics of medical research and the ethics of artificial reproductive technologies, what do we find? Well, we have a serious report of the National Academy of Sciences from 2017 that essentially says the following. Look, we should continue with somatic gene therapy. When it comes to genome editing, we should be much more cautious. There are experiments that need to be done still at the basic level, and if any protocol were to be created, that protocol has to be monitored very carefully. Now, you understand that when the Chinese doctor comes in and says, I have two babies that have been gene editing, well, obviously that caused a complete surprise. It's nothing more than just surprise. So I conclude with three open questions. And I think the open questions could be understood in this way. That is, given these two perspectives on genome editing, what are the chances of genome editing being carried out according to ethical frameworks? So I want to point out three problems in a way. The first is that if there is a lesson to draw from artificial reproductive technologies, that lesson is that the passage from experimentation to treatment is way too quick. Way too quick. That we have called treatment something that was still in experimental phase and sold it to people because we were somehow exploiting the willingness of couples, the willingness of individuals to have children. So just one case, I have a number of cases there, but if you think about the technique known as intracytoplasmic sperm injection, this is the attempt to create fertilization in vitro by using one sperm that perforates the zona pellucida of one oocyte. Now, that technique was introduced in 1992 in Belgium, and just 2 years later, with only 2 studies on safety and efficacy of the intervention, the American Society for Reproductive Medicine declared that their experiment was now a treatment, meaning a clinical application. I have to say, especially reviewing literature produced by feminist thinkers, that experimentation with artificial reproductive technology might have been a very strange case of experimentation carried out on the back of women. But I don't want to necessarily push this argument. So the passage from experimentation to treatment, given the precedence of artificial reproductive technologies, how should we expect to have the kind of safety-driven, precaution-driven attitude that an intervention on germline modification deserves? The case of Jesse Getzinger that happened in 1999, this was a victim of gene therapy. In fact, gene therapy protocols were shut down for a while. This was a young man of 18 who suffered from a rare metabolic disorder and underwent gene therapy. Second question, I already mentioned that with respect to PGD. Is there the possibility that genome intervention, germline intervention, could actually open up even more the path toward eugenics, or toward a eugenic attitude toward reproduction and procreation? Now, when we use the word eugenics, we are obviously thinking about enhancing. I don't think we should trivialize on that. Right? Not everything is like that kind of eugenics. Certainly, I'm not referring to that. But if we take eugenics in semantic meaning, that is the attempt to perfect human beings, and therefore the attempt to create a better human being, then the question is, do we see something like a eugenic drive in the development of artificial reproductive technologies? Well, one fact, and that is that 1/3 of artificial reproductive technologies is done with PGD. And that means that the folks availing themselves of this particular technique are not even infertile. So they actually use PGD because they want to produce a certain type of child. Final point, and that is the problem of the potential relation between medical experimentation, medical technology, and business. And in the area of artificial reproductive technology, we do know that this is the case. I'd like to put up this particular article. It's a little bit old, from The Economist in 2006, where the magazine documents the fact that artificial reproductive technologies have become indeed an international business. So when we think about the development of science, let's think about it critically. Let's think about it by keeping in mind that the connection between financial interests and the development of science is a reality. Now the Chinese have done it. Well, should we stay behind it? Right? That's the justification many times. And so those are the three final questions with which I want to sort of leave you at the beginning of this series of presentations, for you not to draw immediately a conclusion on the ethics of germline modification, but to have something like food for thought. Thank you for your attention.
Hi everybody, I'm really honored and excited to be speaking with you about the ethics of germline modification. So Dr. Dell'Oro did a great job of setting the landscape, and I'm going to dive a little bit more deeply into an ethical discussion about this technology. So as Dr. Dell'Oro mentioned, we have the case of the CRISPR babies in China. And that announcement prompted several bodies to call for deliberation on the ethics of germline editing. And what those bodies have in common is all of them agreed that this technology is not yet safe enough for the type of use we saw in China. That there might, however, be a time in which it's safe enough. And at that time, perhaps we should proceed with certain uses of germline editing. So for these bodies, it was a matter of when and not so much if. And these conclusions really echoed the report that was put out by the National Academy of Sciences in 2017 that Dr. Dell'Oro referenced. And even though they recommended a lot of caution when proceeding with germline editing, they did foresee a future in which it could perhaps be used under certain circumstances. So they provided or put forth a proposed framework. And these are some of the criteria of that framework. One is that there has to be an absence of a reasonable alternative if we're going to use germline editing in a certain case, and we'll talk a little bit more about what that means. They also said that this technology should be restricted to preventing serious diseases or conditions, and we'll talk a little bit more about that as well. And that it should only be used on genes that are convincingly demonstrated to cause or predispose to one of these serious conditions. So I think that even with such a framework like that in place, there are still some important outstanding questions to consider. One is, are there still ethical issues or concerns even with those types of uses? And I'm going to call those therapeutic uses, and I'm putting them in quotations because germline editing is not therapy as we know it in most contexts. So when we talk about therapy, we usually are talking about a case where there's an individual with a certain disease or condition, and we're trying to mitigate or treat that disease or condition. That would be in the case of somatic cell interventions, like was raised by Dr. Dell'Oro. But when we're talking about germline modification, we don't have somebody with a disease or a condition. All we have are embryos that have certain genetic makeups that, if implanted, might lead to the creation of somebody with a disease or a condition. And it's important to emphasize that germline editing has to be carried out in vitro. So we have to create the embryos via in vitro fertilization, and then do the interventions there, and then implant the embryos. So I just want to draw that distinction. It has many, in my opinion, ramifications to it. I can't cover them all tonight, but some will come into play. And then, even if we're okay with the ethical concerns related to these therapeutic uses, is it really possible to contain the technology with a framework like the one proposed by the National Academy of Sciences to those uses? Or is there going to be an inevitable creep of the technology towards more enhancement type uses, as Dr. Dell'Oro was kind of hinting at? And if that is the case, can we really responsibly proceed with the technology without also considering the ethics of such enhancement type uses? Should we be talking about enhancement, the ethics of enhancement up front before opening the door to the technology at all? And finally, what are the actual benefits of the technology? Because as Dr. Dell'Oro said, an essential exercise in bioethics is weighing risks against benefits. So is there a favorable risk-benefit ratio here? So starting with these therapeutic uses, what are some of the ethical concerns? So as Dr. Dell'Oro flagged, there is this bioethical principle of non-maleficence, and that is the avoidance of harm. And there are several potential harms involved in these therapeutic uses. And the first have to do with these more kind of technical issues with the technology, which are off-target edits and mosaicism. So off-target edits are pretty much what they sound like. You go and you try to edit gene A, and instead you see edits to gene B, and depending on what gene B does, that can be very deleterious to the person that ultimately develops from that embryo if it's implanted. Mosaicism is when not all embryos within a blastocyst pick up the intended edit. So some might be successfully edited, others might have an off-target edit, others might not be edited at all. And that discrepancy between the genetics of the cells and of the blastocyst can lead to developmental issues. And quite unfortunately, it was discovered that the embryos that He-Jong-Q implanted were in fact mosaics. And so it remains to be seen what effect that will have on these twin girls. Now, there are claims that there is a CRISPR 2.0 in the works that can really reduce the frequency of these two things, which have been seen in relatively high frequency in initial research. But that's still early days. We don't know. It's not really tested in this context. And also it's important to note that it would be impossible to rule out either of these two issues in any embryo intended for implantation. And that's because in order to confirm that a cell has been accurately edited, it has to be removed from the blastocyst and sequenced. So you can't remove every cell from the blastocyst and test it because then there'll be no blastocyst left. So there's always the possibility that there are unintended off-target edits or unedited cells lurking in the untested portion of cells of the blastocyst. There's also an issue of increased risk of cancer. So without getting too far into the weeds on this one, trust me, when I say that the research has shown that in cells that are successfully edited, there's an increased risk of them becoming cancerous. So it's a little bit of a catch-22 here, and obviously that's a very scary risk to take on. And even though, again, there are these claims of CRISPR 2.0 that can help avoid some of these issues, it's still early days and it's untested. And then there are these deeper risks associated with our general lack of understanding of the human genome, which Dr. Dell'Oro touched upon. So when the human genome was fully sequenced at the beginning of the millennium, we thought we would see these huge leaps forward in our understanding and treatment of disease. We thought we'd go in and we'd find a disease, one or two genes tied to heart disease, one or two genes tied to this cancer, that cancer, and unfortunately that's not what we found. Instead, we found a whole bunch of complexity that really confounded us even more. So most conditions that have a genetic basis are caused by multiple genes, tens, hundreds, and we don't yet understand the interplay of those genes and how they interact to manifest in disease. And then to add even more complexity on top of that, there's environmental factors. So even if you have, the 100 or so genes that predispose to X condition, you may or may not develop the condition depending on the environmental factors that you're exposed to. And we don't understand that interplay. And we don't understand the multiple functions that these genes are playing and how they're interacting with each other. So is it like going into a sweater and pulling a thread and hoping the whole thing doesn't unravel? We just don't know what effect altering one gene will have on a series of others downstream. So there are risks that we don't even know enough to know exist. That's something else to consider here. There are also risks or ethical considerations under the bioethical principle of justice, which has several facets to it. The first is the allocation of limited resources. So when we're talking about biomedical research and we're talking about medicine, we're talking about areas in which there are very limited resources, so we have to be very careful of how we allocate them and to make sure we do so in an efficient way. And with disease, many diseases don't have any genetic underpinning, infectious diseases, for example. And again, some that do, or many that do, or even most that do, there's also an environmental component to it. And again, the genetic basis is so complex that they don't really lend themselves well to something like genome editing or germline editing. So we're talking about a relatively small universe of diseases that really lend themselves to this technology. think of sickle cell anemia or cystic fibrosis or Tay-Sachs that are single gene conditions, and again, they're the exception to the rule. So we have to think about the opportunity costs with pursuing this technology, which is going to entail a lot of money, a lot of time, a lot of research, a lot of human embryos. And so we should consider, is this an efficient use of those resources? There's also access issues. So this is going to be a very expensive technology. Again, it has to be carried out with IVF, which in and of itself is expensive. And we don't know how much the actual genome editing part is going to cost, but we do have some bellwether examples with the gene therapies that Dr. Dell'Oro referenced. We've had several approved by the FDA the last few years, and those are some of the most expensive therapies to ever come to market. We're talking hundreds of thousands, millions of dollars per intervention. And insurance companies are currently grappling with whether and how to pay for those. So we're talking about a limited universe of diseases that could really be addressed here. And that universe is constrained even more by the fact that not everybody that falls within that universe is going to be able to access this technology. So that's something to consider as well. There are also many ethical considerations associated with the application of germline editing to disability-related genes. And there's so much to talk about there, and I don't have the time to do it, so I'm going to skip it and just raise it for you guys because it wouldn't be fair to just rush through it because there's so much and I wouldn't be able to do it justice. So those are some of the issues with even therapeutic uses. Now, if we say let's move forward regardless, we have to ask, can the technology be constrained to those therapeutic uses? And there are a few, I think, reasons to think that might be difficult. The first being that in the UK, there is a very similar framework to the one proposed by the National Academy of Sciences in place to constrain the use of PGD, which Dr. Dell'Oro touched upon. Because there are, in fact, potential eugenic and actual eugenic applications of PGD. So the UK, acknowledging that, imposed a framework, really similar criteria to the one we just saw with germline editing. And what we've seen, and I think the intention was to limit the application to these kind of clear cases of trying to allow couples to not implant or to selectively implant embryos that don't have certain monogenetic conditions like cystic fibrosis, sickle cell anemia, etc. And what we've seen is over a course of a few years, now the UK has approved the use of PGD for over 400 genes. And not all of these signal a certainty that there is going to be a disease that develops. For example, they recently approved BRCA genes as a target for PGD, and for those of you who don't know, BRCA genes are genes that predispose a person to breast cancer, but by no means signal a certainty that a person is going to develop breast cancer. And so that brings up the issue, or I think a problem with one of the criteria that is proposed by the National Academy of Sciences. How strongly does a gene have to predispose to a disease in order for it to be an appropriate target of gene editing? Is it that you have to have above a 75% chance of developing the disease if you have this gene, above a 50% chance? So there are, I think, questions there that make it difficult to imagine how this technology is going to be contained. There are also difficulties in defining serious in this context. What factors do we consider? How do we factor in the likelihood of death from the disease at issue? We have a clear case like Tay-Sachs, where 100% chance of getting the disease if you have 2 copies of the gene, and 100% chance of dying at a very early age. Versus something like breast cancer with a BRCA gene, not a certainty that you're going to develop breast cancer, and if you do, thankfully, we do have treatments for it, and it's not by any means a death sentence at this point. And that brings me to the second point: how do we factor in whether or not there is actually another type of treatment available? So again, with Tay-Sachs, there is no treatment. breast cancer, there are very good treatments. And how do we factor in at what point the disease onsets in life? So Tay-Sachs, again, at one end, onsets immediately and leads to death within the first few years of life, versus breast cancer, which may not onset until middle age. And there could be very different prospects for treatment 40 years down the road for an embryo that's implanted today. So all has to say there's a lot of complexity here that would have to be worked through. And then there's the fact that people are already advocating, including the Newfield Council in England, which is really a lot like the National Academy of Sciences here, advocating for the replacement of disease-related genes with protective genes. So in their report, the Newfield report, they said, well, we could remove a disease, a gene that predisposes somebody to cardiac disease and replace it with one that would protect against cardiac disease. And this is something that goes beyond even my therapy in quotes. It is an enhancement. It's a medical enhancement, but it's making somebody better than well. So we already see support within the mainstream kind of ethics community for an enhancement type use. And then we have the presence of forces within our society, as Dr. Dell'Oro was touching upon, that are pushing for eugenic technologies, the use of eugenic technologies that have really nothing to do with diseases or conditions. And we see that in the way that PGD is used in the United States. So unlike the UK, where it's heavily regulated, it is not regulated at all here. So you have clinicians who are advertising and providing services to use PGD for couples to select for non-disease related traits like skin color, eye color, hair color, sex, and more recently, IQ. So we already see these forces at work. And to me, that signals that there will be people pushing to use this technology for more squarely enhancement type uses. So that brings me to my next question. If there is this likelihood, or at least chance, that this technology will slide down the slippery slope right into enhancement, can we really responsibly proceed with the technology without first considering the ethics of such enhancement uses? And there's a lot to talk about here. I'm just gonna kind of give an overview of some of the key points, I think. So under non-maleficence, what effect will designing children or the attempt to design children have on the well-being of children? Obviously, there's a lot of parental expectation involved in the act of genetically engineering a child. And we already see in the realm of, in the context of helicopter parenting, where you have parents trying to shape their children through environmental interventions, some problems arising. Studies are showing that children of these parents are experiencing higher rates of anxiety and depression. So what effect will giving parents more control, or at least perceived control, over the destinies of their children have on the well-being of children? And then there's the issue that these expectations will likely be thwarted in many cases. And that's because, again, there's a very complex relationship between genes and traits. And when we're talking about something like IQ, for example, there are many, many, many genes involved, and there are many environmental factors involved. And so it's very feasible to think someone goes in to design a baby Einstein and ends up with an average Joe Schmo. And what effect will that have on the parent's ability to accept their child as is when they were given this perceived ability to shape the child through this very expensive technological intervention? And even though I think it's very difficult to design children, I don't think that will stop people. Again, we already see in the case of PGD, the technology being used to select for IQ, even though I think that's total bunk, to be honest. So again, this is a very deep topic that we could do a whole lecture on, and so I'm just kind of passing over the highlights, but I invite you to consider these issues in more depth. And then we have the issue of justice, again, access. This again is going to be very expensive, and when we're talking about enhancement, insurance is not going to be in the picture. People are going to have to pay out of pocket for this. So even if this this technology can offer some sort of perceived benefit either to the child's well-being or competitive advantage in our very competitive world, this is only going to be accessed by people who can pay the very high price tag, so the rich. And obviously we already have a big issue when it comes to socioeconomic disparities in our culture and cultures around the world. And this could really blow that wide open and add a biological disparity to the mix. So finally, with all of those issues kind of under our belt, we have to consider what are the benefits of this technology. So the main benefit that's being kind of bandied about as a reason for proceeding is that we could allow couples who are affected by one of these kind of simpler diseases, monogenetic conditions, sickle cell, cystic fibrosis, etc., the ability to have genetically related children that are unaffected by these conditions. Now, if you remember, one of the criteria put forth by the National Academy of Sciences is that there could be no reasonable alternative available to germline editing. And the fact is that in most cases where we have a couple that's affected by one of these diseases, there are reasonable alternatives, the main one being PGD. So I would love to get into the genetics with you all, and obviously don't have the time, so take that face value when I say that in the vast majority of cases, a couple affected by a monogenetic condition or one of these conditions is going to be able to make some portion of healthy embryos or unaffected embryos that they can implant using PGD. So there's a reasonable alternative already available in most cases. There are only 3 scenarios in which PGD alone cannot get us to the goal here, which is genetically related children unaffected by one of these diseases. The first one is where you have 2 parents with 2 copies of the same gene for the same recessive condition. Now this is an extraordinarily rare scenario given how rare these diseases are, and it's made even rarer by the fact that the disease at issue would have to be one that strikes relatively late in life. It couldn't be something like Tay-Sachs that kills you within the first 3 years of life, because these 2 people would never have made it to the reproductive decision-making table. So we're talking about a small group of people. And these people could use gamete donation, sperm or egg donation, to achieve a partially related child that's unaffected. Now, that raises the question, is having a partially genetically related child a reasonable alternative to a fully genetically related child that might be able to be achieved with germline editing? And that raises a really important question that I think Dr. Dell'Oro did a good job of raising, but I think in general is not talked about enough in the debates surrounding germline editing, and that is how important is it to have genetically related children? And I'll come back to that in a moment, and I'm almost done here. The second case is one parent has 2 copies of a gene for a dominant condition, and to refresh, that's a condition where you only need 1 copy of the gene to manifest the disease, and the other parent has no or 1 copy. Again, this couple couldn't use PGD. There's no healthy embryos here, but they could use gamete donation to, again, create a partially genetically related child that's unaffected. And then the final scenario is 2 parents have 2 copies of the same gene for the same dominant condition. This is really, really rare, given how rare these disease-related genes are. And this couple would not be able to use gamete donation or PGD to have a healthy genetically related child. So really, this is the sole population, if we think that gamete donation offers a reasonable alternative, that has no reasonable alternative with current medicine to have a genetically related child. Again, this is a really, really small group of people. I mean, it's possible you could count them on 2 hands, who knows, it's very small. Even if you throw in these other people from the top 2 categories because you say that having a partially genetically related child is not a reasonable alternative to a fully genetically related child, if you sweep those people into the mix, and then maybe take some other ones from other categories we haven't talked about that might not be able to create enough healthy embryos to have a successful pregnancy with IVF. Even if you sweep those in, we're still talking about a very small universe of people. that could be really uniquely helped with germline editing. And again, the benefit we're talking about here is not the treatment of disease, but the allowing people who might not have otherwise been able to or decided to have a healthy or been able to have a healthy genetically related child, the ability to do so. So again, what this really comes down to is what importance do we place on genetically related children? How far are we willing to go as a society and the risks we'll take and the resources we'll allocate to give everybody this opportunity? So that's what I will leave you with, and I will pass the mic over to Dr. Romano. Thank you.
I'm coming from the law faculty, so the law school, which is separate from main campus, to talk to you about the international aspects of the regulation of human germline genome modification. I'm a professor of law, and my field is public international law, and within public international law, I also do international protection of human rights. This is necessary for you to understand my background. I do not have any specific knowledge on science, but nonetheless, the right to participate in scientific activities and the right to benefit from progress in science and technology is a fundamental international human rights that has been codified since day one of the whole idea of international human rights. So I'm not ashamed to say that this is a plug for the book that is coming out that I co-authored together with two colleagues of mine, Andrea Boggio and Jessica Ronquist, which is entitled Human Germline Genome Modification and the Right to Science, a Comparative Study of National Laws and Policies. The book just came out with Cambridge University Press. So in the book, we reviewed how human germline genome modification is currently regulated in 18 countries around the world. So we took a sample trying to cover all the countries that do significant scientific research. Plus, we have one chapter addressing Europe as such because of the European Union regulations, and one on international governance of human germline genome modification. So we look at the regulatory environment for each, we look at the regulatory framework, definitions, oversight bodies, and funding for human germline genome modification activities. Then we look at substantive provisions dealing with basic research, animal studies, clinical research, clinical applications, and then we ask the authors, the contributors to every national chapter to reflect on current perspective and future possibilities. So, what did we find in our survey? Well, it's a mess. The overwhelming majority of countries have laws that have been written 10 years ago, 15 years ago, 20 years ago, 25 years ago. When it comes to biological research, that is saying that they have been written before even the discovery of evolution. Many are not based on science. They're based on other criteria that have nothing to do with actual science. They employ definitions that are definitely not scientific. They're full of loopholes, and many concerningly use also criminal law to sanctions violations of prohibitions of different kinds of activities, but they use criminal law either disproportionately or by not providing clear guidelines to people engaged in scientific research about exactly what is allowed and what is not, and what could be punished criminally. I also discovered that there is, as I did this process of dwelling into the bodies of law regulating human genome modification, that there is a strange disconnect, if you will, between international bioethics law, for lack of a better word, and international human rights law. And I developed some ideas of why there is a disconnect, but before I get into disconnect, I have to tell you a few things about international law to begin with. Professor Dell'Oro actually brought to my attention to the fact that probably many of you, if not most of you, might not necessarily have an idea of what international law is and how it works. So forgive me if I take 5 minutes to give you international law in a nutshell. Okay? Alright. International law is the law that governs the life of the international community. And the international community is the community where the major players are states, sovereign states, of which at this point in history there are about 200 of them. Okay? So sovereign states create international law in two ways. One, by concluding agreements, aka treaties, okay? And this is a voluntary act of creation of international law, which is very deliberate. States conclude these agreements, negotiate, conclude them, and then they go through a national process that is called ratification, whereby they transform these international norms into domestic norms. The second way international law is created is through custom. That is to say, our international community, like every community, has certain ways of doing certain things, of not doing other things. And over time, state practice, combined with a certain belief that that behavior is required by the community, creates customary international law. And customary international law is binding for every member of the international community. There's every sovereign state, by virtue of the fact that they belong to the international community. Okay? Now, international law is law, it's binding. But what does it mean that international law is binding? Okay, keep in mind that the international community is made of sovereign states. Sovereign states do not recognize any superior authority. And they are also equal to each other, at least as far as their relationship with international law is concerned. Okay, so they are equal and they do not recognize any superior authority. So how do you enforce law in a community of equals that do not recognize superior authority? Well, in many ways, right? So the distinction between binding and non-binding is already something that I don't think is particularly meaningful when it comes to domestic law, but it's even less meaningful when it comes to international law. And I'll give you two examples. For instance, the prohibition to do human cloning, to clone human beings, all right? It's not contained and spelled out in any binding international legal instrument. It's contained in a declaration of the United Nations General Assembly, but it's not binding because it's only a declaration. Nonetheless, as far as I know, no human being has been cloned yet. So we can say that here we have a non-binding legal instrument that is producing compliance. On the other hand, you can have a very binding legal instrument, like a treaty. For instance, a treaty that prohibits developing nuclear weapons. And you might have a state that defies that treaty and violates it because it develops a nuclear weapon. So don't get too much stuck on the binding, non-binding distinction. Nonetheless, when we talk about law, it's important and it's essential and goes to the core of everything that is done. So, now, this was international law in a nutshell in a few minutes. Now, let me go back to the question of tonight's, the human genome modification, and more specifically, the human germline genome modification. Okay. At the international level, we have, these are the bodies that are the most active or have been active so far. The UNESCO, which is the United Nations Educational, Scientific and Cultural Organization, the World Health Organization, the United Nations General Assembly, and the United Nations Human Rights Council. This is at the global level. Then states also gather together at the regional level in international organizations that more or less replicate the UN structure, but they have only a regional focus. And amongst these, at the regional level, so far, the only activity has been had in Europe through the OECD, which also includes the United States and Canada and others, so it's more Northern Hemisphere, the Council of Europe, and the European Union. So what is that? So at the global level, so far, we have only 3 declarations. Declarations, right? When you hear the word declaration, immediately you should think about not binding. Okay, and are the UNESCO Universal Declaration of Human Genome and Human Rights of 1997, the UNESCO International Declaration of Human Genetic Data of 2003, and the UNESCO Universal Declaration on Bioethics and Human Rights, 2005. So I would like to again to call your attention to the dates of these instruments, 97, 2003, and 2005. This is way before we even discovered CRISPR and the capacity to edit genes. And again, these are instruments that are extremely vague. My personal peeve, is that of the three, the most important one is the 1997 Human Genome and Human Rights Declaration. Well, if you go and read it, that document mentions the word dignity 13 times. And as far as I know, no one knows what the word dignity means as a matter of international law, because there's no agreed definition of the term. All prohibitions say you cannot do anything that violates human dignity. Great. What is it? No one knows. At the regional level, as I said, the only region in the globe so far that has legislated or legiferated in the field is Europe. And we have two organizations. One is the Council of Europe and one is the European Union. Council of Europe has 48 members and includes basically the whole of Europe with the exception of Belarus. The European Union is a smaller club of 28, now 27 members of the United Kingdom left. So within the Council of Europe, we find the only treaty that is relevant when it comes to the question of human germline modification, which is the so-called Oviedo Convention, or more in extent, the Convention for the Protection of Human Rights and Dignity of the Human Being with regard to the application of biology and medicine. So this is a treaty, and treaties are binding, okay? However, a treaty is binding only if the state has ratified it. And if we go and look at ratification, we discover that out of 47 Council of Europe members, only 29 have ratified it. And amongst the countries that have not ratified it, there are Belgium, Germany, Ireland, Italy, Netherlands, Poland, Russia, Sweden, and the United Kingdom. Okay? So the reason why the states have not ratified this treaty, interesting, are very different. There are some states that believe that the convention is not binding enough, is not enough to regulate these important matters, and would like to have more, and therefore they're staying out of it because it doesn't do enough. For instance, Germany is one of those, because Germany is, of all states in the world, probably the one that regulates intervention on human germline modification the strictest. And they do it through criminal law, by the way. And then on the other opposite end, there are countries, or Italy is another one that would like to see the Oviedo Convention to be more strict. And then on the other end of the spectrum, there are countries that they think the Oviedo Convention is too strict, and therefore they don't ratify it because of that. And that includes the United Kingdom, Belgium, the Netherlands, Sweden, and a number of others. Okay. Then the European Union has its own directives and regulations. I will not get into that because European Union law is very complicated and will gain diversion. So this is the extent of international bioethics law. All right, so there is some few declaration, one treaty that has very limited ratification and nothing else. However, at the same time, there is a whole body of international law and a specific branch of international law that is called international human rights law. And that has been around for the past 80 years and is very developed. What are the rights that are included in international human rights law that are relevant when we discuss human germline genome modification? One, the right to life. Okay? Now, the interesting thing about the right to life is that who has the right to life? People that are here in this room, definitely. People before they're born? No. And that's international law is very clear on that. We can go on. Then the right to health, which is not the right to be healthy, but the right to the highest attainable standards of health. The right to bodily integrity. The right to a family. As to say, it includes reproductive rights, the right of women to choose how many kids to have, when to have them, whether to have them or not, and so on and so forth. Reproductive rights are part of that. But then there is also the right to academic freedom and the freedom of scientific research, the rights of scientists, the right to benefit from progress in science and technology, the right to conduct, participate in scientific research, the right to work, which is not the right to have a job, but the right to do the work that you choose to do. And then some very important principles, the principle of legal certainty and the principle of proportionality. And the principle of legal certainty and the principle of proportionality are fundamental principles underpinning criminal law. And so on, freedom of speech, right to travel, and all of that. Now, these rights are codified where? Well, at the global level, in a series of treaties. One is the Universal Declaration of Human Rights, declaration, right, non-binding, but then two treaties. One, the International Covenant on Civil and Political Rights, and the second in the International Covenant on Economic, Social, and Cultural Rights. These three documents together, they are the core of international law. So if we say that international law is the law of the international community, these three documents together, they are understood internationally as the International Bill of Rights. So they are the core of the international law, right? They are so important that have acquired also customary international law status. That is to say that are independent now from the existence of these treaties, right? They have a life on their own, and they are, again, they reflect the most important values of the international law. And then you see these rights codified also and repeated almost verbatim at the regional level in Europe, in the Americas, in Africa, in the Arab world, and in Asia. Okay? Now, besides these instruments, there is also a whole body of instruments that we call soft law instruments. What are soft law instruments? Things like declarations, like the UNESCO declarations that I mentioned before, right? These are instruments that are not yet binding, but they might become binding one day if states' behavior remains in line with what provided in these treaties through the mechanism of customary international law. So, for me, the question, therefore, has, and again, I approach the field of human germline modification as someone who comes from international law, was, okay, this is a complete new development, the advent of CRISPR, that is now, of course, raising very important ethical questions that needs to be addressed and need to be resolved. But these are things that cannot be done by one state alone. Right? We all live on the same planet, right? If even one state decides to approach and regulate human germline modification in a particular way, but then the other states around the world don't do it the same way, then of course the efforts of one country to try to address the very important ethical problems that these technologies are raising are going to be completely frustrating. So that requires a certain level of coordination. The problem is that this coordination so far has proven to be very elusive. It's very difficult. It's very difficult because it sounds like a very truist, but the world is a big place and we understand things in very different ways. Again, there are certain countries that tend to err on the side of giving scientists the chance to do their work with putting very limited limitations and restrictions on them. Others that tend to be more cautious and towards the matter, and they would like to put the burden on scientists to prove that their techniques or their are actually safe before giving the green light. Right now, of all the international bodies, the World Health Organization is the one that has taken the lead in trying to come up with a common regulation that could be adopted internationally to address the question of application of germline modification on human cells. But I wouldn't hold my breath. I don't think that that document is going to actually provide any hard rules for several reasons. One, because the World Health Organization has a very bad track record of being able to legislate on anything. They have produced only one treaty in their history, and it's the Convention Against Tobacco. but there are still diplomats in Geneva that still have nightmares about that process and the World Health Organization. So I don't see a treaty coming out of these efforts of the World Health Organization. Probably what they will do will be a soft law instrument, but again, it will be a soft law instrument that is going to have limited capacity and impact. All of that is very interesting, but in my interactions now with international decision makers over the past 2 years since I've been doing this book, and I had the chance to be involved in these international processes, is that the disturbing thing to me is that I see a complete lack of awareness of the fact that at the same time, while they're trying to develop these standards, there are already very important, fundamental, key principles and rights that are codified in treaties that are binding on states. And so my point is that whatever international regulation will eventually emerge or will be adopted, it needs to be consistent with the full body of international human rights. We cannot pick and choose human rights when we come to that, because all human rights are interrelated, interdependent, non-hierarchical, and inherent. These are the 4 essential qualities of international human rights. So we cannot, for instance, prioritize the rights of the embryo over the rights to health of the people who could be cured if adequate research had been done using embryos to discover a cure for their illness. We cannot prioritize other rights over the rights of scientists to do their work without undue governmental interference. Now, granted, of course, human rights are not absolute. They can be limited, and actually there are important limitations to human rights. But these limitations cannot be arbitrary and must always and are only acceptable if they are essential for the life of democratic society, This is exact terminology that is used in human rights treaties. So religious concerns, political concerns, ethical concerns, if you will, they are not a valid basis for limiting the exercise of international human rights. Again, it's only limitations that are acceptable in a democratic society that can be applied. All right, so I think I have done overtime, about for a long time. Okay, I leave it at that. Thank you very much. Yes.
Well, I want to thank, again, each one of our panelists for providing very rich and substantive presentations, both individually and as they interact with each other synergistically. I think, sure.
I forgot one thing. Sorry. Okay. Last thing, we're going to have the symposium at Loyola Law School on March the 13th on the challenge of the creation of a global regulatory regime for human germline genome modification. You're all invited. I will use the network of the Bioethics Institute to send out an invite to everyone and an RSVP. The room is big. Please do come, right? And we will be happy to welcome you to the law school. Thank you.
But you don't have a reception like this?
No, we don't. No food or anything.
So I'm sure each of these presentations, again, individually and collectively, probably have elicited some questions from you all. So we would now like to take the opportunity to give you a chance to be able to pose those questions to our panelists. So I think the way we'll go about doing that is if you could stand up or raise your hand, and we will probably we'll have some way of being able to identify you, and then if you could pose your question to whomever you'd like to pose it to, and then we'll proceed that way. Yes, there's a gentleman right here.
How are you? Is germline a definitive? Oh, I got out one. Is germline editing a distinctive bright line or not?
and why?
Well, can you explain the question? A distinctive bright line in the sense of
In comparison to other, non-competing, hereditary DNA.
no, I mean, I think it is, I'm sorry, try to respond. I think it is fairly specific an intervention from strictly scientific theory. I think the real question is whether the connection with purely somatic gene therapy is such that the passage from one to the other can be maintained firmly distinct and in a way separate. So my impression is that if we look at the trajectory of scientific development by done in basic research, we should say that somatic gene therapy has in fact brought about the other possibilities which are entailed by genome intervention at the germline. I think that the potential for a transition from one to the other might actually be the case also from the point of view of the ethical judgment on the two, in the sense that the kind of ethical possibilities that were envisaged at the level of gene therapy in the somatic field will eventually spill over into the ethical framework of the other intervention.
Well, if I can add, so as far as the international consensus is that somatic intervention, it's okay. There's no problem with that. It's the question of the intervention on human germline cells that is, of course, raising some alarms, because, of course, the question of the creates a trait that can be inherited. But then even there, we need to distinguish apart between the various steps of scientific research, from the bench to the bed, right? So there are states that prohibit everything. They prohibit basic research, they prohibit clinical trials, and they prohibit clinic application. There are some states that allow basic research, but they restrict clinical trials and they prohibit clinical application. As far as I know, there is no state in the world that has already okayed clinical application. No one goes that far. Some states goes as far as allowing clinical trials. But for this, for me, one of the things that is problematic is that some states in the world, for instance, they prohibit the creation of embryos for research. So they say you cannot create human embryos and research on them, period. Some say you can do it, and you can do it up to 12 days or 14 days after the creation, and then you need to stop, and you need to destroy it. The states, to me, that say you cannot create human embryos for research, period, I think that that position is not consistent with their international obligations under international human rights treaties. I think that's very difficult to reconcile. Others, so that they are, but again, there's no consensus. So the question is that is a bright line. It is a bright line, yes, but at the same time, once you start getting into the details, then again, the attitudes vary a lot around the world and with the international community.
I do have a question here, because your presentation also was quite interesting touch on the different regulatory aspects of the problem. But the first question is the following. Okay, so given the current framework of human rights, which hinge on the rights of the scientists, then what is it that the Chinese scientists did wrong?
Chinese scientists,
I mean, because given that framework, why isn't the Chinese scientist able to say, look, there is a right to scientific research?
No.
This is ultimately what I did, and therefore.
Okay, so I love the fact that, if I remember correctly, outside there is a table before coming into this room, right? And you have some stickers and some buttons of the institute, right? Right. Is it your motto that says neither black nor white.
Neither black nor white.
Exactly, so exactly the situation. So what did the Chinese scientists do wrong? The Chinese scientists did a lot of things wrong, right? It violated both Chinese law and violated international law. For instance, like one of the fundamental principles of international human rights law is the right not to be subject to scientific experimentations without one's consent. Can an embryo give consent? Of course not. Can the kids who eventually were born out of this, did they give consent to the procedure? No. Did the parents give consent? No, they couldn't give consent because they were not informed of what the scientist was going to do. So a lot of rules have been violated there. So the question is that it's not that simple. Yes, scientists have the rights, human beings have the rights, patients have the rights, everyone has their rights, but we cannot simply prioritize one set of rights over the others. We need to take them all into consideration. And yes, it's complicated, yes, but the task of governance is about finding solutions, not just pointing out problems.
Thank you, Vince. Dr. Dell'Oro, all three are everybody. So we're at a faith-based institution, Jesuit, LMU. So Dr. Dell'Oro, you know me, so I had to check on my phone because in the topic of discussion of this expertise, there's no mention of morality. So going back into research, I checked on my phone, there's an 1887 book by the German philosopher Friedrich Nietzsche on the genealogy of morality, a polemic. And it goes into treatises of the evolution of moral concepts with view to confronting moral prejudices versus, specifically Christianity and Judaism. So can you weave any of that into from things that are transpiring in this modern day and age for scientific research, medicine, bioethics? Any thoughts?
I mean, I believe that we have been talking about ethics all along. I think one can distinguish between morality and ethics. If you want, morality refers to kind of code of behavior that a person or a society adopts. Ethics is ultimately the attempt to articulate critically that code of behavior by way of scientific reflection or by way of legal regulation. So I think we have been talking about ethics all along by saying that, of course, the scientific possibilities opened up by germline modification are not immediately to be enforced or made available without careful ethical reflection. So in that sense, the question of morality has been amply addressed. To me, what remains open after the three presentations is the question of the relation between morality and legality, morality and regulation, ethics and regulatory aspect. And here is where, on the one hand, one has to, of course, distinguish without separating. Clearly, we should distinguish ethics from the law, right? At the same time, it seems to me that still scientists operating against a regulatory framework do have their own morality. By that I mean, do have their own ethical integrity. And so the question of what that ethical integrity contributes to the type of research they are developing, I think stands in the background of the conversation here. Because this has been a problem for a long time. So let me just give an obvious example. Germany, right? So Nazi Germany, in fact, before Nazi Germany, Germany was one of the countries with the best laws on experimentation with human subjects. They had the best law regulating experimentation on human subjects, even including laws regulating animal experimentation, and yet the professional integrity of the scientists and the existence of regulation did nothing to prevent the kind of experimental procedures that took place later on in Nazism. So I can appreciate the separation or the distinction between law and morality, but I do believe that in the end the question of the professional integrity of individual investigators and where that professional integrity is rooted remains for us that are thinking about bioethics the essential question. So I'm not saying that the regulatory framework is not important. I can appreciate the fact, however, that the regulatory framework might not be as capable of taking into account all the kind of concerns that we might have as human beings driven by a certain type of moral code, or perhaps driven by a certain type of religious code. So that's the best I can say.
Thank you, all three of you, for your information. I enjoyed the talk. I'm a second year bioethics master's student, by the way, everybody. So my question more so is about the fact that it was mentioned that this sort of technology is ahead of itself in terms of the fact that we're not ready to see this kind of thing happening in humans just yet and still it's happening anyways. So two-part question in a sense, what is the difficulty in a sense, stopping the train in its tracks if it's already progressed so far? And in terms of the research, how do we ensure more rigorous research with scientists who are maybe incentivized to produce good work and good work quickly, in terms of being in competition with other research scientists and that kind of thing? Like, what are the difficulties that we might see from that perspective?
Thank you. So definitely the technology is ahead of the ethical discussions and certainly the law. I think it adds a lot of urgency to these ethical discussions, and that's why a lot of these bodies have come together in the wake of the Hey John Q announcement. But they haven't been that effective yet. And I think there is this sense that, well, now the race is on. Now China's doing this, and a scientist in Russia has announced that he also intends to move forward with germline editing and implantation of edited embryos. And a lot of people then say, well, then we should ramp up our efforts and try to catch up so we don't get left behind. I see that argument. I'm not really for it. I do think that caution is really important here given the stakes, and I think generally we proceed with scientific advancement by letting the science get ahead of the ethics and then dealing with the cleanup later. And I think the stakes are so high here that that's not the right way forward. So I am in support of these being more of a warning sign that we should be delving into the ethics more deeply now, rather than speeding ahead with the science and kind of surpassing an ethical discussion. In terms of incentivizing, good science, there is the ability, and nobody's really saying at this point that we shouldn't be researching using. Well, some people are saying, but the general consensus is we should be proceeding with research applications, meaning that we're not going to actually implant embryos, but we should be exploring the technology more in the petri dish without implantation. In the US, though, we cannot really use public funding for that for that type of research involving human embryos given current law. And then maybe I'll.
Well, please, like, even in the case of the United States, right, modifying genetically an embryo and implanting in utero is not against the law. You cannot get public funding to do that, but if a billionaire wants to set up his own private research institute and do it, can be done. There might be violations of other aspects of criminal law, yes, but there's not the criminal statute that prohibits doing that, does it?
No criminal statute, but FDA law. He would violate FDA law.
Yeah, it would be violate FDA law, again, other things, but there's not a prohibition for that specific. Anyway, so that was not my point. My point is that, of course, science is always ahead of the law. That's the nature of the law. Law always tries to catch up. Like, first scientists discover something, and then all of a sudden everyone raises their hand and say, wait a second, we need to regulate this, and then eventually they will catch up. But personally, I'm not that pessimist on these things. I think that it's great that we have ethics. It's great that we have this conversation because they allow us to anticipate problems. Right? Ethics thinks about issues in abstract and from a philosophical point of view, but by doing that, it establishes some very basic frameworks that then are flexible enough to adapt to any circumstance that might arise. As long as we get our ethics clear and very well in our mind, then we can address any technological and scientific development, and then law eventually will reflect the ethical discussions and concerns that happen there. So, of course, are there going to be hiccups along the road? Yes. Are there going to be rogue scientists that are going to do something that is against both national law and international law? Yes, it will happen. Is this going necessarily to be a systemic problem? I don't think so. I mean, throughout history, the scientific community has proven to be very well capable and able to regulate itself through mechanisms that have nothing to do with the law, that have to do with reputation, have to do with being able to be a respected member of the community. Those mechanisms have proven to be, throughout history, more effective in regulating scientists than any statutory law.
I think in the area of genetics, scientists do not necessarily have that kind of splendid record you are actually invoking. I think that since the beginning of the 20th century, eugenic laws have been implemented within states, including the US, with the support of the scientific community. I believe that part of the issue you are raising is the issue of the relation between scientists and ethics, science and law, as one that, rather than being understood in terms of an extrinsic relation of one to the other, ought to be integrated in the personal moral integrity of the scientist. In other words, science ought to be able to say, we are pursuing this particular goal, and we are aware of the fact that this goal is morally plausible for these particular reasons. And we are open up a conversation within democratic society for this particular process or this particular progress or dimension of progress to actually be supported by the public or to be denied by the public as a plausible development. So the idea that, the democratic society stands somehow on the side and eventually intervenes later on to correct what scientists have already done when the gene is already out of the battle, strikes me as being a very problematic way of proceeding.
Well, I'm not saying it's the way it should proceed, but I'm saying it's the way that historically has proceeded.
Yeah, which is the reason why we have had so many problems.
Well, yeah,
Right. So in a way, the history of the progress of science in areas like gene therapy or artificial reproductive technology is not a history of caution. Right. It's a history of sudden application of experimental experimental interventions in the form of treatments for the sake of, well, you feel the blank space, I don't know. Or for the sake of financial incentive, for the sake of exploitation of patients' vulnerability.
For the sake of
you can name.
for the sake of discovery, of doing what scientists are supposed to do, which is finding truths, finding things, finding how the world works.
Yeah, but that seems okay. I mean, this is I appreciate the point, but you know, we are no longer living in a concept of science that is purely theoretical. So in a way, what we discover is actually what we do with what we discover. The connection between science and technology is such that no scientific discovery is without immediately some form of practical application. Therefore, some kind of effect upon society, which all of us end up paying. You know, that's why we have to proceed with caution. With the precautionary principle should not be a kind of external constraint posed upon the scientist, but a principle interiorized by scientists in their own way of proceeding. That's all I'm saying.
I want to be mindful of the time, so perhaps we could have one more question, and then we can continue the conversation further in the reception following.
So, well, can you maybe comment on, we're thinking in terms of limits, contextualizing the limits that we're thinking about for humans within a larger ecological framework. So if we're supercharging humans, or somehow I have this impulse I need to reproduce myself, is this being framed, or how vigorous is there with this balancing against, kind of the larger ecological domain in which we're living, without veering off into, Paul Ehrlich type of, doomsday scenarios, but still being cognizant of the burden that human beings are placing, and how supercharging us or our interventions not only affect us, but these larger networks.
So, thank you for the question. I do think it raises an interesting point, and that is, and it goes back to kind of my point about the allocation of resources. And is it wise, I think the question might be, is it wise to put so much resource towards making sure that we all have the ability to fulfill a preference to have genetically related children, when, one, we're facing kind of bigger issues with the impact of humanity on the environment? Am I getting at your? And also a lot of children out there that could be adopted, and what effect will kind of this fulfilling the drive to have biologically related children at kind of any cost with any environment or with any technological intervention have on those two issues, the environment and then kind of the unparented children of the world. And I think those are valid questions to be considering when we're talking about allocating resources towards what ultimately is a reproductive technology.
We continue later.
Well, once again, we want to thank you all for coming this evening. Again, there is a reception to follow just outside the doors here. You are all welcome to attend. And thank you all very much. We hope the conversation can continue.
May I add one thing, in addition to thanking Dr. Brown for moderating, in addition to the reception, we are offering free germline modification.